Hey YouTube, in today's video let's talk about the bisection method, which is a form of the bracketing method. This method is used to find zeros or roots of the equation in the form of f of x equals 0. In order for a root to exist, f of a times f of b must be a negative number. For example, in this case, if you take f of a, it is a negative number, and if you multiply by f of b, which is a positive number, it's a negative outcome. That tells us there is at least one root. It doesn't tell us how many roots. And in the case where f of a times f of b is greater than 0, there could be a root or there could be no root. For example, in this case, we have f of a, which is positive, and f of b, which is also positive, which f of a times f of b is positive, and there's no roots. However, here, if we take f of a is a positive number, and here f of b is a positive number, f of a times f of b is a positive number, but there is, however, two roots. And in this case, it's underneath, and there's three roots, so we don't know, there could be 1, 2, 3. For today's example, let's solve the equation f of x equals to 8 minus 4.5 times x minus sine x. If you graph this into Desmos or Wolfram Alpha or somewhere, you'll see that there's a root roughly around 2.3, 2.4. And if you didn't know that there was a root, you could just, like I said, take two intervals, say bracket a to b from like here and here, and f of a times f of b would be negative, so you would know there is a root. Now, how to solve this? First off, you're gonna make a table that looks like this. Then you would choose your lower bound and your higher bound. In our case, let's say we take 2 and 3. And if we take the midpoint of that, it would be 2.5. F of A would be 3.0918. F of B would be negative 4.864. And f of ai plus bi divided by 2 would be negative 0.5568. You always take this, and then to check which bound it's within, you know that a negative times a positive would give you a negative for the f of a times f of b to be less than 0. So you know that it's this one. So basically, now you know that 2.5 is the lower bound, and no, 2.5 would be the higher bound, and 2 would be the lower bound. So then you write down here the lower bound and the higher bound. Then you evaluate it at, you check what ai plus bi divided by 2 is, which is 2.25. And then you evaluate f of ai, which would be 3.0918. F of bi, which would be negative 0.5568. And then ai plus bi divided by 2 evaluated within the function would be 1.376. So we check this is positive. In order to make f of a times f of b a negative number, we have to take the negative one, so this one, which is evaluated at here at b. So we check with the midpoint, we see that the lower bound would be 2.25, the higher bound would be 2.5. If we take the midpoint of that, that would be 2.375. And then we evaluate ai in the function, which would give us 1.376. We evaluate bi in the function, that would give us negative 0.5568 ... And then ai plus bi divided by 2 evaluated would give us 0.434. We see the midpoint is positive. In order to make f of ai times f of bi negative, we would have to take the bi. So then we check this one and bi, and we see the lower bound would be 2.375, the higher bound would be 2.5, and we see the midpoint would be 2.4375. So in this case, our 0 is here, and if we continue this process, this number would get much more accurate. And there you go. That's it. Thank you.